Today we're going to be going over chapter 18, which is the heart anatomy. The heart's location is inside the mediastinum. It is superior to the diaphragm, deep to the rib cage, and medial to the lungs. The covering of the heart is called the pericardium. We have a fibrous pericardium, which is the outermost layer with dense irregular connective tissue. Then we have a serous pericardium, which has two layers. The first is the parietal pericardium, which is the bottom of the fibrous pericardium. The second layer is the visceral pericardium, or also known as the epicardium, which is the layer outside of the heart itself. In between these two layers is a pericardial cavity, which is space filled with serous fluid. Pericarditis is inflammation of the pericardium. This happens because your serous membranes stop making serous fluid, and it causes cardial friction rub. Cardiac tamponade is when large amounts of inflamed fluid goes into the pericardial cavity. Now we're moving on to the layers of the heart wall. First we have the epicardium, which is also the visceral pericardium. That is the outermost layer of simple squamous epithelium. The middle layer is the myocardium. This is made of cardiac muscle fiber. It has intercalated discs and it is striated. It is connected by desmosomes and gap junctions. The innermost layer is the endocardium, which is made of simple squamous epithelium. This layer smooths out blood flow. Next, we're going to be talking about the heart chambers and vessels. The atria are the upper two chambers of the heart, which receive incoming blood from the body. The structures in the atria are auricles, which are flaps to increase volume of atria and to pump more blood. Then we have pectinate muscles, which are the ridges inside of the atria. Then we have the fossa ovalis. It is just a hole that is patched after birth. Now we have the veins entering the atria. The right atrium receives oxygen-poor blood from the superior vena cava above the diaphragm. The inferior vena cava brings oxygen-poor blood from the body below the diaphragm. And then the coronary sinus brings oxygen-poor blood from the heart. The left atrium receives oxygen-rich blood from the four pulmonary veins. Now we have the ventricles, which are discharging chambers and basically the actual pumps of the heart. The first we have is the interventricular septum, which just divides the ventricles into the right and left sides. We have the trabeculae carneae, which are the irregular ridges of the muscle, which mark the internal walls of the ventricular chambers. We also have papillary muscles, which play a role in the valve function, and they project into the ventricular cavities. Now we have the right ventricle. The right ventricle pumps blood into the pulmonary trunk. The pulmonary trunk routes the blood to the lungs, where gas exchange occurs. Then we have the left ventricle. This ejects the blood into the aorta, and this ventricle is stronger because it pumps blood throughout the whole body. The aorta is the largest artery in the body.
Blood flow through the heart. There are two ways blood flows through the heart. The first way is pulmonary circuit, which controls the right side of the body. It goes from heart, lungs, and back to heart. The second way is systemic circuit. It controls the left side. It goes from heart, body, to heart. The left side is thicker because it pumps to farther places in the body. The heart has four valves. There is the AV valves, which is the atrioventricular valves, and then the semilunar valves. Atrioventricular valves have two, tricuspid and bicuspid. The tricuspid is located on the right side, which helps control blood flow to the lungs. Bicuspid is on the left side, which helps control to the body. Semilunar valves have two other ones. Semilunar valves have aortic valves and pulmonary valves. The aortic valves go through the upper diaphragm and pulmonary go through below the diaphragm. Some clinical problems seen in heart valves are incompetent valves, which shown up here just have a weird look to it. It doesn't provide enough blood, and it usually happens in bicuspids. Then the next one is valvular stenosis, which just gets really stiff from scar tissue. Coronary circulation with arteries. There are two main coronary arteries. The left coronary artery comes off the aorta, which feeds the following. Anterior intraventricular supplies anterior, which walls both of the ventricles and intraventricular septum. The second one is the circumflex, which feeds left atrium and posterior part of left ventricle. Right coronary artery supplies blood to the right side of the heart. It has two types of arteries, marginal artery and posterior intraventricular artery. The marginal artery feeds the lateral part of the heart, and the posterior feeds the remaining part of the posterior ventricles. Coronary circulation also has veins, which is located on the back of the heart. The cardiac vein collects blood from the heart, and there's three different types. There's the great, middle, and small. The great cardiac vein collects blood from the anterior septum. The middle cardiac vein collects blood from the posterior intraventricular septum, and the small cardiac vein collects blood from the right inferior margin. The second one is the coronary sinus, which brings blood back to the right atrium. How blood travels from oxygen poor to oxygen rich. It starts off from the superior vena cava, inferior vena cava, and coronary sinus. The superior vena cava drains the upper body above the diaphragm, and the inferior vena cava drains the body from below the diaphragm. This continues on to the right atrium and then goes on to the tricuspid valve. This also continues to the right ventricle, and it goes to pulmonary semilunar valve, pulmonary trunk, and then the right and left pulmonary arteries and lungs. All this right here are oxygen poor. From lungs, it changes over to oxygen rich and goes to right and left pulmonary veins. The pulmonary veins then move on to the left atrium and then move on to the bicuspid valve. The bicuspid valve will open up and push the blood throughout the left ventricle. The left ventricle will then push it through another valve, the aortic valve, where the aortic valve will push it through the aorta. The aorta then splits into two, which is the coronary artery and the heart. It also goes back to the coronary sinus, which returns as oxygen poor. The second version is body, and it's oxygen rich, and as soon as it goes throughout the body, it goes back through the superior vena cava and an inferior vena cava as oxygen poor.
The intrinsic cardiac conduction system sets the basic rhythm for the heart. The action potential is initiated by pacemaker cells. The sequence of excitation is as follows. The sinoatrial node, or the SA node, is located in the right atrial wall and sets the pace for the heart. The SA node typically generates impulses at about 75 times every minute. Its rhythm, called sinus rhythm, determines the heart rate. From the SA node, the impulse travels through the atria and the internodal pathway to the atrioventricular node, or the AV node, located above the tricuspid valve. The impulse is delayed at the AV node for about 0.1 seconds, allowing for the atria to respond and complete contraction before the ventricles follow. The AV node conducts impulses more slowly. From the AV node, the impulse travels down the AV bundle, or the bundle of His, to the right and left bundle branches that run down the interventricular septum toward the apex of the heart. Then the impulse travels to the Purkinje fibers located superiorly in the walls of the ventricles, and the heart contracts as a whole. The electrocardiograph has 3 deflection waves. The P wave represents atrial depolarization, the QRS complex represents ventricular depolarization, and the T wave represents ventricular repolarization.
There are two main intervals in the electrocardiograph. The PQ interval marks the beginning of ventricular excitation, and the QT interval marks the beginning of ventricular depolarization through ventricular repolarization. The heart has two main sounds. The first sound, lub, is the AV valves closing. The second sound, dub, is semilunar valves closing.
There are 4 sites on the chest to listen to. This allows you to listen for a heartbeat. The first one is aortic, the second one's pulmonary, third one's tricuspid, and the fourth one is bicuspid or mitral. These allow you to listen for a heartbeat. Cardiac output has 4 different types of volumes. End-systolic volume is the amount of blood ventricles contain when atria contract. The end-systolic volume is when the amount of blood is there after ventricles contract. Stroke volume is the amount of blood one ventricle has in one heartbeat. And cardiac output is the volume of blood pumped by one ventricle in 1 minute.
Clinical problems of the heart. Tachycardia is heartbeats over 100 beats per minute. Bradycardia is below 60 beats per minute. Atherosclerosis is the hardening of arteries and clogs blood vessels. Congestive heart failure is the heart can't pump enough blood.